Is it good today?
Yeah.
I wore my wood coat for a while. Okay. So we were going to finish a problem. Which one? 2000. October, November 2002. II. Did we do the equation of the curve part?
Yes.
Everybody's cool?
Okay.
Right.
The C is +2.
Yep. Is that what we got? Okay, so let me go ahead and write down the equation of the curve itself for October, November 2002. I gave us what equation? Y equals
1/3 and then times 1 plus 2x raised to the 3 halves plus 2.
Everybody good? Thank you for giving that to her. All right. The point. So now it says find the equation of the curve. Yay, we did that. And then it says find for part II. It says find the point at which the curve intersects the y-axis. So yes.
Is November, December 2002 the same as October, November?
Is it the same wording?
Yeah, and I noticed on all the other packets that you have November, December 2002, and then a problem, and then the exact same one, but it's labeled as October,
Which
November.
is completely possible that they reused the questions back then.
Mm-hmm.
Not so much now. We won't see it now, but not, yeah. Okay, so this one says it wants me to find the point at which a curve intersects the y-axis. What do I know about something that intersects the y-axis? Specifically, x is 0, right? So what we're going to do, what's that? Plug in 0 for x. So we have y is equal to 1/3, 1 plus 2 times 0 to the 3 halves plus 2. So y is equal to 1/3, that's 0 plus 1, right? So 1 to the 3 halves plus 2. Y equals any 1 to any power is 1. So 1/3 plus 2.
7, 6.
Yeah, yeah. So 1/3, 2 1/3, or 7, yeah, because you got to come 7/3, yeah. Because you have 6, yes.
What does it look like?
It's October, November 2002. It's at the bottom of a page. It says the gradient on the point xy is equal on the curve of square root of 1 plus 2x.
Oh,
You see it? Yeah, II. And so it just wants the ordered pair. So 0, 7/3. It was 2 points. This would be a 1-point question nowadays, though.
What?
What?
The whole thing?
It's just that piece.
Oh.
Yeah, because it's fun. It's telling you to find the y-axis, the y-intercept, basically. Where did we get 1/3 from? We did it yesterday. We did the actual problem yesterday. We took the integral using U-Substitution. Okay. Yes.
So what's like the hardest type of problem that we would do with U-Substitution?
I think that's the hardest. Any of them. Any of these types of problems, U-Substitution seems to be the, I guess not hardest, but probably the one that you have to think most about.
But it's always the stuff that's in parentheses.
Yeah.
That's like raised to a power, or that's inside the square root.
Correct. Yeah. Did we do, on the front page, number 9, dy dx equals 12 over?
Front page. I don't think
let's do
so.
that one. Okay. So this one's May, June 2002. And it's number 9. And it says a curve is such that dy dx is equal to 12 over 2x plus 1 to the second. And the point 1,5 is on the curve. Okay, so far so good? So we got the problem now. It says so the normal to the curve at P crosses the x-axis at Q. Find the coordinates of Q. So the normal to the curve at P, which we know P is 1,5, crosses the x-axis at Q. And so what do we know about Q? Right, so y is 0. Okay? And then it says find the coordinates of Q. So it tells me that the normal to the curve at T.
So the opposite.
So what is the opposite reciprocal? Bless you.
Thank you.
Let's talk about if in a normal situation, if I told you to find the normal,
Mhm.
what would the first step be?
Find the derivative.
Find the derivative.
Okay.
Very good.
So
Right.
you take the integral?
So,
we have the derivative.
so we have the derivative.
So we just have to find opposite reciprocal.
Right. We have the derivative. Does that make
Mhm.
sense?
Yeah.
Normally, if I say find the normal, you would say, oh, I got to take a derivative.
Uh-huh.
But guess what? They gave us a derivative. How do I know this is a derivative? Because it's dy dx
Mhm.
equals. Okay? So what would the second step be? First step says find the normal. Take a derivative. What would we normally do next?
Plug it in.
Plug what in?
The x.
Plug my x value in. The x value would give me the slope of any tangent line. But I'm looking for a normal.
So it'd be the opposite.
So it'd be the opposite reciprocal. So we're eliminating step one where we had to take a derivative. Does that make sense?
Yeah.
So we're going to actually find the slope by plugging in the x value. What's the x value?
1.
1. Is everybody okay with how that came about?
Yeah.
By the process so far? Okay. Somewhat. Okay. So you understand that for us to find a normal, you have to take a derivative. But because the derivative is already done, we're good to go. Yeah. Okay. All right. So then we got 12 over
9.
9. So reduce that
4
by 3,
4.
4/3. Okay. Cool. So what is 4/3? Yes.
So that's the 4/3 is the slope of any tangent line,
Correct.
and the normal line is the opposite reciprocal of the tangent line, so it's negative 3/4.
Perfect. Everybody okay?
Right.
Anybody want to stop, think about it, talk about it, ask about it? Everybody cool with what that meant, how that went down?
Yes.
Cool.
Mhm.
Now, how do we go about? I'm going to get some new markers because those with whatever she's cleaning with, they look really light to me. Bringing out the big girl. I'm excited.
Doing the normal line and then what else?
The other is a tangent line. Yeah, tangent is when it touches at one place. Normal is where it hits it.
Perpendicular.
Yeah, where it hits perpendicular.
So if we just skip this step, we just have to do the...
We didn't have to do the derivative.
Okay.
Okay, because it was already given to us. Okay, so now it wants the normal line still. We're close to having what we need for a normal line. We have a slope. We have a point. Use my favorite formula, right?
Right.
So my favorite formula is y minus, y minus 5 equals slope
Negative 3/4.
negative 3/4 times
X minus
X
1.
Minus 1.
Good.
Yep.
That right there is the actual normal line, normal equation at that point. I don't have to clean it up if I don't want to. I can. It's not a big deal either way. It's not a bad one to clean out. Y minus 5 equals negative 3/4 x plus 3/4, right?
Yes.
And then add 20/4 over. But to get a
Add
common-
5.
Add 5, right? Which is also known as 20/4. Yeah. So I get y equals negative 3/4 x plus 23 over 4. Yes.
Would it be okay, like, to add 5 over and then be adding 5 to 0.75, like, put it in decimal format?
I multiplied everything by 4.
I'm fine with that. Yeah.
Oh, yeah.
Cleaning it up is however you clean it up. They're going to look at it and go, cool, you got an equation.
Because even if it's a fraction or a decimal, it's still right.
Yeah, yeah. Ultimately, what are they looking for here? They're not really looking for
Now
your
we
equation.
find the point.
They're looking for your point,
Mhm.
right? So what do I need to do?
Plug in 0 for y.
For y. That's right. Because it says it meets the x-axis at q. What is q? So if I know it meets the x-axis, right? It's the x-intercept, so y is 0.
Mhm.
So 0 is equal to negative 3/4 x plus 23/4.
Mhm.
Everybody okay?
Yeah.
So I would subtract 23/4 over. So negative 23/4 equals negative 3/4 x. Multiply both sides by 4/3, right? Negative 4/3. Yeah.
Well, can't you just, it's really just negative 23 equals negative 3x, because if you multiply both sides by 4, they go away.
Multiply everything by 4, they go away. That's
Right.
a good way to look at it.
Negative 4, too. Get rid of the negatives.
Get rid of the negatives. I like that. You guys are learning the old lady tricks. Exciting. So really you would have 23 equals 3x.
23 over 3, which is 7 and 2/3.
What'd you get?
23 over 3.
Yeah,
which
which
is 7
is-
and 2/3.
7 2/3 is x. Beautiful. And I would write it as an ordered pair, because that's important to them that you show your ordered pairs. Okay. So far, are we okay?
Mm-hmm.
That was part I. How many points was that worth?
4.
Yeah, it's not a bad 4-pointer. Okay, now, what does the next part say?
Find the equation of the curve.
Find the equation of the curve.
We have to integrate the derivative.
We do have to integrate the derivative. So, I have dy dx. Okay, part I. I have 12 over 2x plus 1 squared. And Nick, you've said it a couple times now. You've said, the problem I see is it never says use substitution rule. Okay, but why does this automatically kind of click in my brain that I'm going to need a substitution rule? Why is
Because you can't spread that thing out.
you can't spread that thing out the bottom, first of all.
Right. But if it was in the top, like if it was 12 times 2x plus 1 squared, we could.
We could.
Yeah.
But what it would be now? Yes.
When you bring it up to the top, it's going to be the negative.
It's going to be a negative
Yeah.
power. So there we got an issue. So on the bottom, we're good to go. Can you see a mistake somebody would make out here in math land where they just FOIL it out in the bottom and be good to go and take its derivative or integral and say, yay, I'm good, and it's wrong. Because you don't know, you cannot do it from the bottom. It has to be from the top. So when you flip that up, you no longer can expand it like you would like to do. Okay? So this is where the U-substitution must come into play. Yes?
Can we put the 12 into the front?
You can put the 12 in the front. So like you're going to agree you're going to integrate both sides, right? I would do this. Just like that. I would make the 12 go for the ride and then handle the 12 later. 12 is just a constant that just happens to be part of the problem. So on the left-hand side, okay, and I bring the dx over, right? It's better if I have the dx over. So dy is over here. And remember, this is called a differential. It's okay. It's just showing me that I'm allowed to take its integral. So on the left-hand side, what is the integral? It's just a y.
And then the u is 2x plus 1.
Okay,
Yeah.
so we're going to write that out. So you're telling me u is 2x plus 1
And du is 2.
is 2 dx,
Right.
Yeah.
right? So, yeah, you guys are comfortable, I think. So let's kind of look at what's happening. The 12 is going to come down for the ride. We're going to pretend it's not there for a moment, right? We're going to rewrite this whole thing in terms of u. So at this point, this is u
To the negative 2.
And then du.
And for me to have a du, I need a 2 dx, but I have a
But
dx.
you need a 1
Put
half.
2 and then 1/2 on the outside.
2,
So that turns to 6.
right, and then 1/2. So there's my du.
Yeah.
Is anybody having trouble with that one step? That right there is the key.
Yeah,
Yes,
can you explain
I
it?
sure can. So do you understand that u is this?
Yeah.
Does that make sense? Do you understand the derivative of u is this? Okay, so ultimately I'm trying to get rid of anything that has an x. So I'm going to rewrite this as u, and I want to rewrite this as du. Okay? For it to be du, it has to have a 2 attached to the dx. So I'm just going to place a 2 there, which changes everything. So if I pull out its reciprocal, I've not changed everything. This now becomes du, and this out here indicates that I used the 2, but I'm still removing the 2. Okay? So now, y is equal to 6. What's the integral of u to the negative 2?
U to the negative 1 over negative 1.
Everybody okay with
Yes.
that? Plus c. Why does it have to be plus c? Because I don't have an a and a b. So the
Why
only
is it -1?
up here,
Add one.
over here. Which
At the
one?
bottom of the column.
Because remember, whatever we added 1, and then we put it on the
Right,
bottom.
right.
Right. Okay. So
Yeah,
now,
I forget the negatives. I'm like, isn't it just -3? But I
Ah,
forget
yeah,
to
you go
add it when
right.
you go down.
so ultimately, you got to clean her up a little bit. So do you agree 6 and -1 can be called -6? And then do you agree u to the -1 that can flip down, right? You can put 1
Just
over.
over U, right?
Right. And then really, instead of u, what would it be? 2x plus 1
Right.
plus c. Now, it's not wrong if you leave it u to the -1 and put 2x plus 1 in there, have 2x plus 1 in the -1. I'm cool with that. But to me, it's harder to evaluate, plug stuff in.
And now do we use the
Now you use the 1 and the 5.
Huh?
Yeah.
Like you what?
Yeah.
Use
Yeah.
P 1 and
For
5.
X and Y.
Right.
And solve for C.
Yeah.
Okay.
Yeah. Okay. So now we're going to plug in 1 and 5. Why the
Right.
1 and 5? Because that's what they gave me in the first place.
Yeah.
So 5 is equal to negative 6 over 2 times 1 plus 1 plus C.
Yeah.
5 is equal to negative 6 over 3 plus C. And then 5 is equal to negative 2 plus C. 7 is C.
Yeah. And then just insert that
In
there.
here where
Yeah.
it's kind of pretty.
Yeah.
So, kind of pretty. I didn't say it's really pretty.
So I have a question.
Yeah.
I don't know if I remember.
Okay.
To insert it back into.
Well, the actual question says, find the equation. So they're not looking that you know C. They're looking that you know the equation. So to get that last point, you've got to put it in there.
Okay.
Okay.
Would there be a situation where it would be a problem just like this, but they don't say they don't give you the 1.5?
They will always give you the A.
Because you couldn't have done
You
that
couldn't
without
have.
it.
We need 2 plus C, right?
Yeah, you have to find plus C in order to be able to do
Because
the
you
rest.
can't have the third variable.
Right,
Get them the
right.
equation.
You need it. You need it to do these problems.
Would we ever have to do the III first?
What is the III? Do you guys remember that? Some of you.
Oh, that's
Yeah, that's stupid stuff, right? What is it?
Wasn't it like with the derivatives with real world problems, right?
That's what it was.
Yes.
It's called related rates.
Yes.
Yeah, you're right. What would you have to do? A point is moving along a curve in such a way that the x-coordinate is increasing at a constant rate of 0.3 units per second. X-coordinate is increasing over time. How do I represent that?
Is it given equation fine?
Yes, you guys are starting to ring a bell, right?
dx over dt. So those one with dy over dt is equal to something, and then you put the dx over dt,
Yes.
and then you plug in whatever that rate is.
Yes.
It gives you that.
Exactly right. So let's talk. So let's do it. So a point is moving along a curve such a way that dx, the coordinate of x, is increasing, so it's changing over time, at a constant rate of 0.3 units per second, right? Find the rate at which the increase of y coordinate, right? So we're trying to find dy over dt when, so it's question mark, when x equals 1. So remember, it's given, equation, find. What does it want me to find? It wants me to find dy over dt. Okay, what's the given? Well, dx over dt is 0.3 and x is 1. Okay, and then what is the equation?
The equation we just found.
The one that we've already been using.
The one we've been using is sufficient.
12 over, or no, that's the derivative.
So
It's
6.
bound. That thing.
The negative.
So, if, let's think out loud for a minute, outside the box for a moment. If we take the derivative of y equals negative 6 over 2x plus 1,
The 12.
what are we going to get?
The 12 over.
We're going to get the 12 stuff, aren't we?
Yeah.
So yeah, it's the derivative of what we just found,
Hmm.
but you already have it, so you don't really need to do it. But what's the only difference? This is called the related rates. So instead of dy over dx equals stuff, it's going to be dy over dt is equal to,
The dx.
and then what's the what's the thing? 12 over
2x plus 1.
2x plus 1 squared, and then
dt.
dx dt
Just
attached
multiply
by the relation over time.
and then you plug in. the
Now
x
plug in what you know.
very end.
Plug in what you know. And how many points was it worth? It's a 3-pointer. Back in the day. Nowadays, it probably wouldn't be worth as much. So what would it be if I was plugging things in? I'm trying to find dy over dt. I've got 12 over
12 over.
2 times 1 plus 1 squared. And then
Okay.
times 0.3, right?
Yes.
Clean her up a little bit. And that's what, 3 squared?
squared,
So
9.
9 times 0.3.
Which one is it?
That was part I of that first one, the second on the front page.
So 2 over 5.
What is it, 2/5? Okay, cool. So dy over dt is 2/5. What do you think?
Would you want to put in decimal because they gave you the the other rate in the decimal?
You could.
0.4.
0.4. Question?
Why'd you have to multiply by 0.3?
That's the dx over dt. That's the change of x over time. So if we can recall back in the day, remember the watermelon problem that I kept talking about? This is a watermelon type problem, where something is changing over time. Dx over dt. We didn't do that one?
I don't remember one.
Never remember
Never
that.
did a watermelon. I'll do a watermelon
What
one.
was changing? Oh, it was the radius
Of the
in relation
watermelon.
to the.
Mm-hmm. We did it. It was not a pretty one. Yeah.
So on the left it's always dy over dt, and then on the right you have to attach a dx over dt.
But don't sometimes they give you dy over dt
Sometimes
and
you solve for,
dx?
yes, that's right. Sometimes they give you dy dt and you solve for dx dt.
And if you know that over there it's dx over dt, you have that, which is 0.3, so then you just multiply that by that and plug in 1 for x, because they said x equals 1.
Absolutely.
So is it always when you do the problem, it's always dy over t, and then times whatever the equation is, and then times the dx?
That's
and
all
you
it
just
is.
solve for whatever you're
That's all it is, yeah.
Okay.
They're not meant to be terribly difficult at this level, and so it's meant to be an easy couple points if you got the concept. Okay, so that was a good, nice problem. If you ask me, let's try to find another one that kind of goes that same route. Oh, see that one more. Shoot, that's a volume. That's next time. Yes.
Oh, there was a question I had for you, was like about where you used the chart thing. I'm not
Yeah.
sure which one was that.
You do main 2003.
That's pretty.
The top one,
Yeah, that's a good one. The first one.
too. No, I remember either 1, 3, or 10.
Yeah. Let's do both. Let's do that whole question. Yeah. Part 3 and 10. You notice I didn't circle 10 because I had not, at that point when you had the sub, I had not taught you how to do U-Substitution. That's why I didn't circle any of those. Now you're capable of doing U-Substitution, so they're part of it. The only thing you cannot do on these pages is if it says show the volume. You don't know how to show the volume yet. The volume of rotation. It's really cool.
Never mind.
Yeah, that's next chapter. You'll like it. I think you guys will be cool with it.
Wait, Miss K?
Everybody but Strain here. Yes.
So for this test, will we have anything for volume and things like that?
No, that's chapter 17. Yeah, so you're learning the majority of this. You're learning the majority. The hardest part is this chapter. Chapter 17 is pretty easy. Because you know how to do the concept now. It's just using a formula. Okay, so we're going to do 3A. I like this type of problem. It's just a basic differentiate this with respect to x. Okay, so first of all, what does the word differentiate mean?
Right.
Derive, take a derivative of, right? So tell me what you should do first.
Flip the x squared.
Right, because you don't know how to take a derivative of something that's in a denominator.
Can you do that? Is that like a thing to take a derivative?
Well, yes, use the quotient.
Use the quotient. Low D high minus high D low low low.
I prefer to flip it up.
I prefer to flip it up too. It makes it less steps. So derive. What's the derivative of 4x? 4. And then the derivative of this 6 goes for the ride.
Times
Negative 2 comes to the front.
x.
And then you put a what here?
Minus 3.
Yeah. A lot of people are like, which way do I go with it? So clean her up a little bit, and you got 4 minus 12 over x cubed, and you're done. That was worth 2 points.
Probably like 1.
Killer.
Back in the day. I know. Now, part B. Now, have I talked to you why they put A to B occasionally on these? Okay.
Because you use,
Because
they don't have any
doesn't II use the information before and A and B are separate?
Correct. Exactly right. IV, all them. They have some relation to each other.
Right.
They mean use what you've learned, use what you've done, use the beginning of the question, whatever it is, you're using what came before. And then A and B are two separate entities altogether. Yes.
But aren't they related somehow because they're in the same question?
In this particular problem, they're related by looking the same, but they have nothing to do with each other.
Or by the same concepts, because there's only one question for each concept on the actual test.
Exam, right?
Right.
Mm-hmm. So this is going to ask us to integrate.
There's only one of each question on the exam.
Pretty much, you have 10 questions total.
What?
Oh.
What?
Yeah, don't you think that? That's why it's so hard for me to teach you everything, because you have to kind of boil it down and figure out.
Oh my gosh, I didn't know that. Wow.
Cool.
So now
Well,
this
that's
is when we would do
something.
union.
Do what?
The U.
Do we have to U?
No.
We don't have to U.
Wait, what's your pass rate in this
Regular.
class? It's like the exam, not your class.
Yeah, 60%.
Are we gonna have another like big review before the test?
Oh, absolutely.
Okay, good. Cool. Cause like I got everything, but like the very first stuff we did, a little bit iffy. But ever since this chapter, it's kind of there.
It kind of pulls it back together because this reviews a whole lot. We've
Like
done a lot of derivative
surds
stuff
and
again.
indices.
I was gone all of October when we learned this.
That.
Like all of this derivative stuff.
But this might be a good review for you then, or at least a learning experience for you. Yes.
Is it a good thing to look at the tests, the past tests that
All
you
the
have?
time. Just
Yeah.
start printing tests off of, our favorite source. Start printing tests off of that with the mark schemes. Do them and check them. Do them and check them. Do them and check them. That's what I would do. Okay, integrate. No, we don't have to use U-substitution because we don't have binomials in here. Does that make sense?
Yeah.
We don't have quantities. The only thing I would suggest is do what first?
Flip it to the top.
Flip that guy to the
So
top.
pretty much whenever something's in the parentheses, you'll probably.
Yeah, parentheses or square root. Okay, so what is the integral of 4x? 4x
To the second
squared over 2. Everybody good?
Squared.
Correct? Yeah, you clean her up to 2x squared. And then 6 goes for the ride. X to the,
-1 over -1
and then
DX.
dx
Plus C.
plus
Good
c.
job. dx is gone.
Right.
Clean her up a little bit and you're done. So this would be 2x squared
Minus 6x
over x
plus c.
In this case, we do just leave it as.
Leave it as C. There's no A and B. There's
Right.
no X and Y, so you're good to go. All right, so that was worth, a good 5 points back in 03. It'd probably be worth 2 right
Oh
now.
God, that is just wild.
We could literally pass the O3 test.
You could kick butt on the 03 test.
Why do they do this?
The AP exams did the same thing. They got progressively more difficult.
Why?
Well, it's just the way of the world.
Screw us.
But we're not.
It's the way of the world. It's the way of the world. As the SAT comes, it gets a little more difficult. The ACT comes, but
This
you
is
guys are
Okay, the
learning
ACT
different
was
things.
like-
BS.
You guys are learning a lot differently than I did.
Except for the science portion.
Science portion,
killed
you just
me.
gotta read the
It was
chart.
common
You
sense.
I
need
didn't even have time to
science.
read everything.
That's what D. Ward told me.
This is May,
Yeah, I
June.
literally guessed on it. 96.
Same thing, May, June 2003.
This is just number 10.
Yeah,
It's just like that other one we did.
it is. Okay, the first thing says, the equation of the curve is y equals the square root of 5x plus 4. And then it says, calculate the gradient of the curve at the point where x is 1. Calculate the gradient. Gradient means
Slope.
How do we find a slope?
Take the derivative
Derivative.
and then plug in your x value.
That's it.
Yes.
Okay?
Hold
So, you guys with me?
Yeah.
Calculate the gradient. Oh, gradient means slope. How do I find the slope? I take a derivative. Yay.
Whoa.
Now, this, I need to write it as 5x plus 4 to the 1/2.
So this is when you use U.
Well, that would be integration. We would use U-substitution. What do we call it now? Chain rule.
Or, yeah.
Oh.
So you
Right.
carry the 1/2 together.
Okay, so y prime, dy dx, right? Is
1/2
1/2
1/2
times 5x plus 4 times.
What do you think? Does it ring a bell?
Yes.
The 1/2 comes to the front, you rewrite the inside, you subtract 1 whole. Oh, I gotta take the derivative of the inside, attach it to it, clean her up a little bit.
Yes.
I would say 5/2, and then 5x plus 4 to the negative 1/2 is cool, or you could flip it down if you want. It's up to you.
You distribute the 1/2.
I just put the 5 up here. I do not distribute the 1/2 through. Yes.
Just the negative half, or is it just the half?
Say it again.
Like for 1/2?
Here?
No, for first time.
In the first
Or the
time,
second one.
it's
No,
that's a negative.
Yeah.
Because we added one
You
or
subtracted
subtracted one. Yes.
Yeah.
So if you did bring it down, what
It would look like this. 5 over 2 times the square root of 5x plus 4. Yes.
How do you know to bring the 2 down and not leave it up with the
It's in the
5?
denominator.
Oh, okay. So then that's you just kind of bring
So
that
this
below.
guy can come to the
Yeah.
denominator and pair with it. This is certainly perfect as well.
Okay.
Okay. Okay, so what's the next piece say? Yeah, a point on the curve xy moves along the curve in such a way that the rate of increase of x
So
has a
D-
constant rate of 0.03.
Given
So dx dt is 0.03, right? dx dt is 0.03. And then it says find the rate of increase of y, dy dt, we don't know, when x is 1.
That's
So
the same.
it's the same type of problem.
it's 0.3, now it's
Yeah, we have the derivative.
We have the derivative, but instead of calling it dy dx, we will say here, dy dt equals this times dx dt. That's the only thing that changes. Yes?
Didn't for part I we need to plug in 1 for x?
Plug in 1 for... Oh, did they ask you to plug in 1?
Well, they say calculate the gradient of the
Okay,
curve.
so if we plugged in 1 here,
5, 6.
so 5 halves times 5 times 1 plus 4 to the negative 1 half, right? So 5 halves, and that's 9 to the negative 1 half, which is what, 1/3? Yeah, 5, 6.
and then
So literally this answer, because x is 1 still,
you just do
is 5, 6
6
times.
0.03.
Right. Whatever that turns out to be. Yes,
Wait, where did .03 come from?
it came from this part II.
Oh,
Yeah.
Which one is it?
May, June 2003.
Yeah, May, June 2003. Number 10.
Alright.
Yes.
Then the part III is like where we have the little person and we do the highest one minus the lowest one.
Yep.
How do you
And
know what you use?
I'll set you up. What's that?
How do you know what you use person?
Because it says area, right? Area. Yep,
Mhm.
you're going to use that little person. We don't even have to draw it, though. It's the integral of the square root of 5x plus 4, and it's going to go from the y-axis, and so 0 to 1. And then dx is attached. So, you integrate that? Yay, life is good. Now, here's the question. I should rewrite this as to the 1/2. Oh, am I using my original or am I? Yes, I'm using my original because it asked me to find the enclosed by the curve, which is the curve we started with. So this should be to the 1/2.
Yes.
What type of problem is this now? It's a U-substitution.
Right.
So what is U?
U is 5x plus 4.
Yeah.
Du equals 5. You need to
5
put a 5 and then 1/5.
That's it. You need to put a 5.
You don't have to put a plus C because you have a friend, right?
Good.
You have an A and a B, so you don't need to C.
That's right. You guys are kicking. So we have 1/5, and that's integral of u to the 1/2 du. Perfect. So what is the integral of u to the 1/2? Would be u to the 3/2
Over 3/2.
over 3